Day 2 of section 5-3, theorems involving parallel lines. Objective is still going to be the same as it was yesterday. Apply theorems about parallel lines and apply the midpoint theorems for triangles. Here's your class opener to get started. Try to find the missing lengths. First problem. Given points x, y, and z are the midpoints of segment AB, BC, and AC. So looking at the diagram on the right, I realize that x is the midpoint of AB, y is the midpoint of BC, and z is the midpoint of AC. Okay. Using that to find these missing values. So number 1 tells me that AC is 24. So all the way across the bottom I know is 24, and I'm looking for the value of xy. Since I know it's connecting the midpoints, it should be half of that, and it should be 12. Looking at number 2, it tells me that AB is k, so all the way from A to B is the value k, and it wants to know how big is YZ. Well, YZ is connecting the midpoints, so which would be half of that, so it's just half k. Number 3, XZ, so right here, is going to be 2k plus 3, and we were supposed to figure out what is BC. Well, BC is the opposite side, which should be twice the size of the segment that connects the midpoints. So double 2k plus 3, and we should get 4k plus 6. Problem number 4. It gives me that AB is 9. We have BC is 8. AC is 6. And we're supposed to find what's the perimeter of triangle XYZ. Well, XYZ is this smaller triangle inside. So looking at the smaller triangle inside, I know that segment XZ should be half of BC. So if BC is 8, XZ is 4. And likewise, all the other segments of the highlighted triangle on the inside are half of the outside lengths. So XY should be 3, and ZY should end up being 4.5. And if we're looking for the perimeter, I just need to add those values together. So add 4, 3, and 4.5 together, and what would you get? 11.5. Number 5. Let's see, if the perimeter of triangle XYZ is 24, and if I look, triangle XYZ is this smaller triangle inside of there, and I know the perimeter of that is 24. It says, find the perimeter of triangle ABC. Well, triangle ABC is the larger triangle on the outside. It doesn't give me any of the segment values of the triangle inside, but I know that for every piece on the small triangle, the outside triangle is twice the size. So the perimeter for the outside triangle is just going to be twice as big as the perimeter for the triangle on the inside, so it should be 48. Six, name all the congruent triangles. Let's just go through and highlight them. So if I try to look for triangles that are congruent to each other, I can see that AZX should be congruent to ZCY. Reason for that is if Z is the midpoint, I know that these two pieces are the same size. Since we have congruent angles here, we also have congruent angles over here. I can get angle side angle that those two are going to be congruent to each other. Now, I can also get that those triangles happen to be congruent to triangle up here. Same reason, I can go through that segment CY is congruent to segment YB. The larger angle C here is going to be the same size as here. And I could even get to that angle CYZ is going to match up to angle YBX. And you might even note that the triangle on the inside is congruent to all of those. So if you look, we really end up with 4 triangles that are congruent to each other. Okay, a proof. Let's start by filling in. We know that we're going to have our statements and reasoning column. We know that our first statement is just going to be copying the given information. So we have parallelogram ABCD, and we have a lot of information. We know opposite sides are parallel, opposite sides are congruent, opposite angles are congruent, the diagonals bisect each other. So a lot of information. We'll figure out which part we're going to use for this problem. We also know that M is the midpoint of segment AB. And this is all given. So let's look at how we're going to try to prove that MO is half of AD. In this chapter we learned that in a triangle, if you connect the midpoint of one side to the midpoint of another side, that segment is half the distance of the third side. So as I look at this problem, if I look at this larger triangle, triangle ABD, if I could show that M is the midpoint of AB and O is the midpoint of DB, then I would know that MO is half of AD. Well, I'm halfway there. The given already told me that M is the midpoint of segment AB. So the only thing that I have left to show is O is the midpoint of DB. And I know that since it's a parallelogram that the diagonals bisect each other. So I'm going to write that back down. So I know that AC bisects segment DB. And our reason is diagonals of a parallelogram bisect each other. Now, if the diagonals bisect each other, then I know that O is going to be the midpoint. So O is the midpoint of segment DB. And my reason is going to be definition of segment bisector. Now that I know that O is the midpoint of segment DB, and I know that segment OM connects the midpoints of two sides of a triangle, I have my final answer, which is MO is half of AD. And the reason is, if a segment joins the midpoints of two sides of a triangle, it's half the distance of the third side. and your closure for today. What did you already know about today's lesson?